Okay. Hello. Once again, I guess. Good morning, everyone. We're just going to take a couple of minutes to wait for everyone to join the meeting, and then we can start. If I may ask everyone to mute their microphones when we do the presentation so that we don't have any interruptions. Thank you.
Hello.
Yes, hello, we can hear you quite well. If I could just ask you to mute your microphone for the time being, because when we do the presentation, we'd like to do this without any distractions or interruptions, and we'll address all the questions in due course. Thank you.
Okay.
All right. Again, good morning, everybody. Good to have you here today with us at Global Tech School. First off, I guess, like I said, once again, it's best to keep your microphones muted so that we don't have any sound interruptions during this brief presentation. If you have any questions in the course of this webinar, please feel free to ask them through the chat window in Zoom. As some of you who already been at our webinars know, we answer those questions in a text window because we actually have a dedicated team of professionals right now that are just waiting for questions. So anybody who asks questions, just in case, sometimes it happens that we don't have enough time, and so not all questions get answered in the course of the webinar, but in this case, all of them are documented, and we'll get back to you with answers as soon as we can. All right. So my name is Anton. You've already seen me here in Global, heard me here in Global Tech School. I've been doing some presentations on topics from oil purification to bitumen production, etc. So it's good to see you here. And today we have a bit of I guess, a different topic. We're going to talk about wind turbine maintenance and servicing. And specifically, we will discuss changing of oil in gearboxes in wind turbines and servicing the step-up transformers in wind turbines. So I guess we can go to the next slide. All right. As you can see on this graph, it's very obvious that alternative energy sources are introduced more and more often, and they augment or even replace traditional power sources. And the use of wind power to generate electricity on an industrial scale is actually gaining quite a momentum worldwide. Wind turbines convert the kinetic energy of the wind into electricity, and these are used both in everyday life, in households like home wind turbines, smaller ones, and large, of course, industrial scale wind turbines that you can sometimes see in the countryside. And the power of such turbines ranges from anywhere from several kilowatts to several megawatts on the bigger side. So on this slide, you can see how the total power output of wind turbines in the world has grown from 1996 to 2019. And as you can see, the power capacity has increased more than 100 times, and there is a steady trend towards further growth of this power output. Next slide, please. Once again, I kindly ask everyone to mute their microphones because we want to do this without interruption as much as possible. Okay, we'll go on nevertheless. So for big wind generators, the maintenance of which we'll be talking about today, the component that is subjected to the most load is the gearbox physically. So the cost of the gearbox and the generator itself, it's about 34% of the total cost of the wind turbine, approximately. And the general principle of the wind turbine is the same, regardless the size. The wind flows and passes through the vanes, and drives the vanes, the rotation of the vanes, and the rotor in turn. And the rotor drives the low-speed shaft of the gearbox. And the gearbox, by planetary gears, raises the speed on the high-speed shaft from several tens to actually several hundred RPM, and transmits this torque to the generator shaft. And in this entire rotor gearbox generator train, the gearbox is probably the most heavily loaded unit. Next slide, please. So for smooth operation, the gearbox contains large amounts of gearbox oil of high viscosity. And depending on the design of the gear unit, the average volume of that oil can be anywhere from 200 to 450 liters. However, as mentioned above, the number of big wind generators increasing. So in this day and age, the volume of oil on average has grown to about 900 to 1200 liters. And during the operation of the gearbox, the gear oil is exposed to quite a significant thermal and mechanical stresses, as well as contamination with metal particles. Therefore, in the process of maintenance, the purity of the oil is monitored in accordance with the ISO 4406 standard. And the level of purity should be at least 17/15/12 or better. And endoscopy of gearboxes is also a very good method to check for pitting of the surfaces of the gears. Next slide, please. So the main reason for this pitting and chipping of the gears, and as a result, the breakdown of the gearbox as a whole, is the loss of lubricating properties of the oil, an increase in cavitation in the gear oil, and contamination of the oil with metal particles. So when we hear about new wind farms, the wind farms that just been installed, it's important to understand that a new wind farm, basically this is the period when the gears are running in. And so the effects of the metal abrasion at this time are the strongest. And the breakdown of the gearbox means a replacement, because in 95% of cases, repair and restoration of a gearbox performance is only possible at specialized facilities. And such a failure of a gearbox means quite a significant downtime of the wind turbine. But replacing the gearbox is obviously a complex operation. It costs a lot because the height of the wind turbine mast sometimes is 160 meters or even more. So you can see how this can be difficult. Next slide, please. So in terms of maintenance of the gearbox, it's important to monitor the quality of the gearbox oil and to make complete replacements of that oil on schedule. And this oil in the wind turbine gearbox, on average, must be changed about every 2 years. And today, this oil change involves a lot of manual labor. And during the replacement process or the oil change process, hoses are used with about 24 plastic canisters for used oil and the same amount of new oil as well. So this process can be roughly divided into several stages. So first is the preparation of the workplace on site at the wind farm. Then we have to lift the workers, the materials, and the tools up to the nacelle. Then we have to drain old oil from the turbine into those plastic canisters and lower those canisters down using a hoist that the wind turbine is usually equipped with. Then we take canisters and pour new oil into those canisters and lift those canisters up to the nacelle. And then we obviously have to fill the gearbox with that new oil and then lower those empty now containers from the nacelle and then clean everything to remove any spills of the oil that can and probably will happen. And then all the workers and materials and tools are lowered back to the ground. And then we remove the old oil transported away from the wind farm and from the wind generator. Usually this whole operation involves about 4 or 5 workers. In the term of time, this entire cycle of oil change and replacement of oil filters in the gearbox can take at least 1 working day. So it's quite a big process. And if this process is done in this manual way, the operator of the wind farm faces some problems. First would be high man-hour costs. Obviously, this requires a lot of people to work in coordination. Another problem is possible low quality of the work. That would mean that oil gets spilled or may get contaminated on the way to the turbine, etc. It takes a while to replace that oil, so we're looking at a long downtime of the wind turbine, and as a result, a reduced amount of generated electricity output to the power grid, and also additional transportation costs for delivery of clean oil to the wind generator and for the removal of used old oil from the site. And of course, there is extra wear on the lifting equipment because the hoist has to be used to take that oil up and down, up and down. And during one working shift, just 1 wind turbine can be serviced by this team. And we at Lopor here developed a comprehensive approach to replace that oil and to also clean the gearbox. This approach also includes maintenance of step-up transformers in wind turbines, but more on that in a minute. So changing the gearbox oil can be done with the CMMG and CMMGL model units. And what they do is they mechanize and to a degree automate the process of changing the oil in the gearboxes. And there is a whole range of advantages and benefits compared to doing this manually, traditionally. And then there are the CMM 0.6 and the CMM 6R units that purify oil, and oil meaning the oil in the step-up transformers. And then there is the TOR5 station, and that performs diagnostics using the insulating oil in the transformer. But yeah, we'll talk about those a little bit later. Let's first concentrate on the machines to change gearbox oil. Next slide, please. So here is the CMMG, and it's a completely mobile unit installed on a 2-axle trailer. Excuse me. It's designed to be towed by the same vehicle that transports the maintenance team. And on the trailer, there's a box with well-positioned doors and roller shutters so that the unit can be easily maintained, and there's good access points everywhere. There are 2 oil tanks in that trailer. Each has a capacity of 950 liters. One tank is used to collect old oil from the turbine, and the other one is used for transporting new clean oil. And it also has heating installed inside. So there are also 2 drums of reels, rather, with hoses, and those reels are motorized for winding and unwinding the hoses. So any point of that unit is easily accessible for inspection or maintenance or whatever the case may be. The external shell of the unit is made of aluminum sheets, and the tank with clean oil has thermal insulation, and it's also sheathed in aluminum jacket. And on customer request, we can design the outer shell of the control unit and the oil tanks for cold climates, cold resistant design, or for for example, hot, tropical, humid climates. The length of the hoses that come with the machine can vary from 40 to 180 meters, and that depends obviously on the height of the wind turbines at the client's wind farm. So the machine itself, I guess, is divided into several compartments or areas. It's equipped with a generator. It comes with a DJ 1200 BGTE gasoline-powered generator that outputs three-phase 10 kVA power at 380 volts. And that generator obviously provides autonomy in the power supply of the unit. So when you arrive at the wind farm, you don't need any shore power, anything like that. Second compartment is the machine proper. And this compartment contains a Hydromax gear pump with an electric drive for extraction of used oil. And there is a gear pump with a drive for removal of clean oil, and a vacuum pump with an electric drive for evacuating the tanks. And the pumps are all connected by pipelines, obviously, with electrically driven valves for automation purposes. Now, also there is a control panel. It has a 7-inch touch screen. It's built on a Mitsubishi PLC. It allows the user to control the valves and control the heating of the clean oil. So the important thing here is that the new oil that we're transporting to the turbine can be heated even before the machine arrives at the wind farm. So as you know, this gearbox oil is quite thick. It's viscous. So heating that oil makes it possible to increase efficiency of pumping the oil up into the gearbox of the wind turbine. And the last compartment is for storage of inventory, spare parts, and what have you. It can be wrenches, cloth, tools, any sort of thing. Next slide, please. Here you can see some of the performance specifications of the CMMG. You can see the oil discharge and pumping capacity, the temperature of the oil, the electrical system. Now it's fully customizable. We understand that in different parts of the world, different electrical systems are used. So that's also something that we can tailor to individual customer requests. And also in the end of the table down there, you can see the weight and size of the unit. As you can see, it's light enough to be towed by a vehicle to the wind farm. Let's go to the next slide and see how it works. Right, so this machine can operate in several modes. First is extraction of the used oil. It can supply clean oil, it can heat oil, and it can flush the gearbox using special flushing or rinsing oil. So let's look at this in more detail. So extraction of waste oil. In this mode, with a vacuum pump, the oil from the turbine gearbox housing is drained into an intermediate tank, and then it's pumped out by the gear pump into the used oil tank. Or it can be actually discharged directly into any container that we can bring along. For example, we need additional capacity for the oil. In this case, the oil will be output into that external tank. And now if we can see the next slide. Now in the next slide, you will see exactly this process. As you can see here, the oil comes into the unit, and then it doesn't go into the unit's tank specifically. It's switched so that you can output the oil to an external tank, which may actually be beneficial in some cases for some applications. Okay, let's go to the next slide. Now let's look at basically what we came here to do is to replace oil. So this is the clean oil supply mode, or delivery mode maybe. This is when oil is pumped into the gearbox of the wind generator. And in this mode, oil goes up to a preset height from the clean oil tank, and it's pumped by the gear pump. And in the process of supply, the oil actually goes through a 12-micron filter to ensure that it's extra clean and works well for the generator for a long time. And there it goes. And okay, this next slide is the, as I mentioned, the flushing of the gearbox using special flushing oil. In this mode, the gearbox is rinsed with oil. that is supplied up to the gearbox by a gear pump, and it goes up there at the pressure of about 5 bar. So that is sufficient to wash away any of the remaining waste, oil or solid impurities, metal particles, or what have you. So quite a handy mode to work with. All right, so the process once we arrive at the factory, at the wind farm, goes something like this. So first of all, the CMMG machine is filled with clean oil at the base, and if necessary, the operator can engage heating mode in the machine even before starting work. So when the machine comes to the wind farm, the oil's already prepared for the output. So the machine is then towed to the wind turbine by the company vehicle, along with a team of workers. Next stage is to prepare the work site, get everything ready, steady the machine, extend all the supports on the perimeter, etc. And then workers, equipment, and materials are lifted up to the nacelle as necessary. Then the hoses are lifted to the nacelle to connect to the gearbox. Then oil and filter are changed in the gearbox. And then we lower everybody down, the workers and materials and any tools that have been used. And in terms of time, this process of changing oil in the gearbox in the wind turbine takes anywhere from 2 to 4 hours maybe. And that's counting from the beginning of preparation on site to the startup of the wind turbine. And obviously this time can depend on a number of factors, such as the height of the turbine, the volume of oil to be changed, basically the more oil longer it takes, the ambient temperature, because that affects the viscosity of the oil to a degree, and of course the human factor. And that means just how well coordinated the team is, how skilled the workers are, things like that, how fast they work, basically. Next slide, please. So just to briefly recap and emphasize some of the benefits of operating such a machine. There is no more need to pump or pour oil from one container to the next and to the next. So the process is quite a bit more direct than using many containers. And one load of oil in the machine is usually sufficient to change oil in 2 gearboxes. If we take a 420-liter gearbox in a wind generator, basically we can do 2 at a time. And in one work shift, it's possible to change oil in 2 wind generators this way. It saves time, and fewer service personnel are involved. There is usually no more than 3 or 4 people required to operate the whole thing. The quality of work is better because there is not as much chance of oil getting spilled, and the new oil doesn't contact with the environment that much. And it's also an environmental benefit because oil is obviously bad for the environment. And since wind farms are aimed at preserving the environment, I think that's a good thing. So the machine, the CMMG, is equipped with a filling nozzle, much like what you would see on a gas station, like a pistol at the end of the hose. And that nozzle has a meter that allows the operator to see the amount of output oil. So all in all, this translates directly into decreased downtime of the wind turbine in this whole power generation cycle. Right, so now let's go and talk about the CMMG-L. Next slide, please. So let's look at this next little machine for changing oil in wind turbine gearboxes. The L in the name stands for light, and you can see it's quite a bit smaller than the CMMG. It's also completely mobile. It's installed on a single axe trailer, again towed by the service team vehicle. On the trailer, you can see there is a box or shell with doors on all sides for easy maintenance and control. Any point of the machine is accessible for inspection and maintenance. Again, there are 2 reels or drums with hoses with motors to unwind and wind the hoses easily. All the parameters of the process and all the valves are managed again by a controller, so it's quite automated. Again, a filling nozzle with an oil meter is installed at the end of the delivery hose. And the machine, again, has several compartments, I would say. The machine proper includes, again, a Hydromax gear pump with a drive to extract used oil, a gear pump with a gear pump to deliver the oil, and a vacuum pump with an electric drive to create vacuum in the intermediate tank. It speeds up the work process, and the pumps are connected obviously by pipelines and everything. There are the controls for starting and stopping the drives and controlling the valves, and of course the box for accessories and tools. And the CMMG and the CMMGL gear oil change units for the maintenance of gearboxes, so wind turbines, are manufactured here in-house with highly reliable, proven components from the leading world manufacturers. And of course, each unit is tested to verify its performance parameters before ever it gets shipped to the customer. On the next slide, we will see, next slide, please. Yeah, we will see the performance characteristics of the CMMGL. Again, the performance of draining oil, the rate at which it drains the oil from the nacelle, and the rate at which it delivers oil up to the nacelle. And once again, the electrical system is fully customizable. It depends on the customer area for voltages, etc. So next slide, please. Okay, so this is the oil extraction mode. This is what we start with. We need to get old oil out of the gearbox. Basically, again, we have three modes here: waste oil extraction, clean oil supply, and gearbox flushing. So in this mode, with the vacuum pump, the oil from the turbine gearbox housing is pulled and drained into an attached tank. But you may have seen in the slide above that the CMMGL doesn't have an internal oil tank. So in this case, you would have an external tank nearby, and you would drain that oil to that external tank. Next slide, please. This is the oil delivery mode. In this mode, we take oil again from an external tank, because this smaller machine doesn't have inbuilt tanks. And the gear pump takes that oil and supplies it to the wind turbine nacelle. And again, the oil passes through a 12-micron filter that is a standard on these machines. Next slide, please. And this is how the gearbox flushing mode works. You can see that in this mode, gear pump supplies oil to the given height at the pressure of about 5 atmospheres, 5 bar. It goes into the gearbox and washes away any remaining waste and solid impurities. Yeah, we can go to the next slide now. Thank you. Okay. So the process is quite similar to the CMMG. It doesn't differ too much. Again, we come to the site, prepare the site, lift all the workers and materials to the wind farm, lift the hoses to the nacelle. We use the hoist that the wind turbine comes equipped with. So now we change the oil in the gearbox, change the filters in the gearbox, get this old oil out into an oil container down below, and again we replace that oil. No, back for a minute. So then we take oil from an external container and pump it up to the gearbox nacelle. And then we wrap it up, pull the hoses down from the wind turbine, and get all the people down as well from the nacelle. And then we just remove that used oil and take it back from the wind generator. And so the benefits of the CMMGL, go to the next slide, please now. Again, there's a lot less hassle with containers with this machine. You just have one tank with new oil, one tank, empty tank to contain the used oil. 3 or 4 people only are involved in this oil change procedure. The quality of work, again, is higher than manual replacement because, again, less chance to spill oil and minimum contact of new oil with the environment, with air, with dust, and what have you. Excuse me. And again, the machine is equipped with a nozzle, with a pistol like on a gas station, with a meter that allows the operator to precisely meter the required amount of oil into the gearbox. And of course, all of this means less downtime, so you can be in and out, change the oil very quickly. Now, let's go to the next slide and talk about some of the other machines for wind turbines. Now, The machines we produce are not limited to oil change, of course, and we offer comprehensive solutions for purification and maintenance of oil for anyone who deals with transformer, turbine, industrial oils, etc. Excuse me. And we also offer equipment for online diagnostics of electrical insulating oil, but more on that later. I'm sorry. So there are transformers up in the turbines, and these step-up transformers use insulating oil. Okay, so they constantly operate with heavy loads and quite variable as well. And as a result, the insulating oil quite quickly accumulates gases and water, and it also becomes contaminated with solid particles. So step-up transformers or wind generators actually fail a lot more often than conventional distribution transformers. And in this slide here, you can see three components of this solution of ours. The CMM 0.6 machine on the right side of the slide. What it does, it helps with drying the oil, with removing moisture from oils, and with degassing the oil. And in the middle, you can see the CMM 6R machine. And that machine deals with oil regeneration. And by that, we mean removal of acids, oxidation, and aging products from the oil. And of course, it also includes filters to remove solids. And on the left side of the slide, you can see the TOR5 station. And that is a bit different because this station allows to monitor the condition of the transformer over time using the oil as a diagnostics tool. Right, so the results of such an approach where everything is done with several machines is quite excellent. You don't longer need to store used oil or pay a lot to dispose of it because you can regenerate and reuse the oil. And there's a lot less downtime for the wind turbine. Oil can be changed and regenerated on site near the unit, or oil can be transported back to base and processed back at the maintenance base if that is necessary. Now let's talk about these machines in a little more detail. So let's go to the next slide and talk about CMM 0.6. And this is a small handy little unit. It helps to dry and degas oil. It goes at the rate of just 0.6 cubic meters per hour. And in one pass, this machine can reduce the gas content to 1.5% and moisture content to 10 ppm. Well, that will obviously depend on the initial quality of oil, but these are good ballpark figures. So the advantage of the CMM 0.6 unit in comparison with units that use a system of rush springs or activated filters is that it uses nozzles, and these nozzles don't really clog. So you can process oil with high humidity and high degree of contamination with this machine. Next slide. Right, so the obligatory specifications table, you can see, first of all, I mean, all of these specifications are good, but I'd like to draw your attention specifically to the dimensions of the machine. And dimensions are important here because if the transformer is on the platform up near the nacelle or inside the base of the tower, the maintenance may become somewhat problematic with a bigger unit, but the CMM 0.6 is so small that it can easily pass through any doorways of the tower. It can be placed on the elevator platform. So it's very handy that it's small, and it can be used to remove water, gases, solid impurities. You can do all of that directly at the step-up transformer, which is usually located inside the wind turbine. And in the next slide, we'll see the regen machine, and this is the CMM 6R. What it does, it regenerates oil, and we already had a webinar on this technology, and I'm sure we will repeat that sometime in the future, but it's quite an interesting machine. What it does, it removes products of aging and decay of oil using a sorbent. But the big thing about this is that sorbent in these columns that you can see, once it is saturated with impurities that it captures from the oil, the machine switches to reactivation mode and then reactivates the sorbent without the need to unload it and take it out of the columns and replace it with something new. So this sorbent can be reactivated several hundred times, actually. A good average figure would be 300 reactivations. So basically, once the sorbent is saturated, the machine starts reactivating that sorbent automatically, And once it's done reactivating, it goes back into oil processing and oil regeneration mode. And it can go through this cycle up to 300 times before the sorbent actually does need to be replaced, because of course nothing is forever. So in the end, by the way, the processing rate is about 0.5 cubic meters of oil per hour. And the reactivation process in the machine takes about 90 hours. Reactivation of the sorbent, I mean. Okay, next slide, please. In the next slide here, you can see again the parameters of the machine, the CMM6R. Note, please, that the processing rate does depend a lot on the quality of processed oil, because when the oil is heavily contaminated, it has a lot of acids, dark in color. It is better to reduce the processing rate so that we don't oversaturate the sorbent too quickly and have the process run at the best efficiency. Once the oil becomes cleaner and lighter and more clear, then we can increase the processing rate to something bigger, and that would be the best way of handling this. Okay, next slide, please. That's the machine in a little more detail if you're interested in its internal composition. But first off, it's built on a metal frame. That's number one here. All of the components are either bolted or welded to that frame. Number two is a buffer tank. And this is an oil reservoir that is used for recharging the machine with oil and to collect waste oil. Number three is the control cabinet, which has controls for recording and displaying temperatures, and I'll get back to it in a minute and tell you why it's important. It also has buttons for controlling the pumps installed here in the cabinet. Number four is a carbon filter. It scrubs the exhaust during sorbent reactivation, because reactivation is basically burning, right? So there is a hot exhaust with stuff that you don't really want in the atmosphere. So it goes through a carbon filter, and that carbon filter captures that. Okay, number five is a pump that obviously pumps oil through the machine. Number six is another pump, and that pump extracts oil and waste during sorbent reactivation. Number seven is a filter, because you cannot do this without filtering the oil. Number eight, you can see are columns. Those columns are filled with a special absorbent medium. Oil is regenerated in these columns. Number nine is a vacuum pump, and that pump creates vacuum in the system during the reactivation of that sorbent. Number 10 is an intermediate tank, where we separate air bubbles from the oil during regeneration, and it's also used for collection and extraction of condensation that forms during the reactivation process. Number 11 is an oil trap and demister. It again condenses moisture and condenses heavy fractions during sorbent reactivation. And number 12 is the control column. So the column, this control column, is different from the other columns because it has temperature sensors, several temperature sensors along the entire height. Now, the way reactivation works, very briefly, is by basically igniting the contaminants in the sorbent and letting them burn out. And that process takes a lot of time, because it resembles a cigarette. Like you have the vacuum pump pulling on that column, and this burning layer starts at the top and moves to the bottom. So you need to control the temperature of the process. You will see the progress of the process by the temperature on the temperature sensors that are installed in the column. Now, the control column has 4 or 5 sensors. I can't quite remember how many, but the rest of the columns only have 2 sensors, one at the top, one at the bottom. So this control column is used to judge how the process is progressing, the reactivation process is progressing in all of the columns. So just by analogy, basically, if you have certain temperature at a certain level in the control column, it's a good chance that the same is occurring in the other columns as well. Right, so the machine is small enough to be mobile. It can be transported on a trailer or actually on a flatbed truck if that is necessary. Right, and let's go to the next slide. Okay, this here is the Torque 5, and this is quite a marvelous piece of engineering. And let me tell you why. So periodic laboratory tests are rather ineffective for diagnosing rapid changes in step-up transformers, because wind farms, as you can imagine, are often located in remote areas, and it does take a certain amount of time to collect oil samples and take them to a lab, have them analyzed, and then interpret those results. So to improve the reliability of these step-up transformers in wind turbines, we've come up with the diagnostic and treatment station, the TOR5. The reason I call this a station is because it's permanently installed and connected to the transformer. Oil from the transformer circulates through the system in a closed loop, and it passes, during this cycle, it passes over sensors, and these sensors measure some data, excuse me, and all of this data is transmitted once every minute to a cloud server, and this information is used to calculate some important parameters such as moisture content and the dielectric strength of the oil, the content of water in the solid insulation of the transformer, and the general oil quality index. And it does so mathematically. So using some indications, there is some very smart math involved that allows us to calculate the remaining parameters of the oil and to diagnose the transformer using the oil. So basically, you can access this information from anywhere in the world as long as you have internet access. And when the content of water in that oil exceeds a certain value, the system switches from simply diagnosing to processing the oil. A valve switches and oil starts going through those 3 columns that you can see in the machine. And in this mode, the water is captured by the sorbent in these columns, and the content of moisture in the oil gradually reduces. So when it goes below a certain threshold, then the TOR5 can switch back into monitoring mode or diagnostics mode and continue looking at our transformer, and it will let us know if something goes wrong again. So when the gas content of the oil rises, the sensors will immediately inform the user about it. And if that happens, the TOR5 can do nothing about gas content. So it's just better to bring about the CMM 0.6 to degas the oil quickly. Next slide. Right. So as you know, wind farms are not only based on land. A lot of wind turbines are based at sea, and we have offshore solutions for these pumps, for these turbines. We have this product line called the Clean Marine. It has a special design to protect it reliably from marine environments where you would have sand, salt, maybe dust, high humidity, of course. It's quite aggressive. So it's well protected, and it can be used on ships, on offshore oil platforms, and in warps, in places where you repair or build ships. And in fact, some of these units are very successful in offshore oil derricks right now. Okay. So to sum this up, if a technical team, a maintenance team that works at a wind farm only has these 3 or 4 globe core machines in the fleet, that team is unstoppable. They can tackle any task associated with maintenance of the wind turbine in terms of oil and transformer. And once again, we have online diagnostics of the electrical insulating oil in the step-up transformer. We can purify comprehensively this insulating oil in the transformer. We can regenerate it, and we can change the oil in the gearbox, which is different oil, but still important, right? So we can change that oil all with these 4 machines. And all of these operations are performed a lot faster and require a lot less labor than doing this like manually, okay? So the regeneration of oil itself, which is an important thing, it again saves money and economizes by allowing the operator to reuse oil and not pay so much for disposal of old oil and for buying new oil. And this concludes this webinar, this presentation for today. I would like to say that I appreciate your attention and thank you all again for coming here. Once again, as this is our usual practice, you can get a certificate of attendance from our managers if you request that. And what else was I going to say? No, that's pretty much it. Again, thanks a lot. Stay tuned. Visit our website and see if we can have some more interesting topics for you in the future. And I'll hope to see you there. Thank you and goodbye.